All right, so today we got in front of us an A1466. Not sure what year this one is off the top of my head, but this one came in for no power issue. I did initially check the PPBUS fuse on the board in front of the customer, and I noticed one side was getting 8.6 volts, the other side wasn't. So it looks like our fuse itself is blown, which means we have a short somewhere that pulled enough current to blow our fuse. I'm going to go ahead and switch over the camera here so we can see what we got going on. So here's our logic board. The first thing we want to do is hook it up to our power supply and see what it draws, or even if it tries to turn on. So we got a green light, and we're drawing 0.03. Basically nothing. If we hit the power button, it cycles down to 0.027 back to 0.03. Very, very minimal difference. Let's turn this off and see what type of logic board this one is, because it'll either be a 3436 or 00165. Hope that was the right number. All right, this one is a 00165. Let's pull up our schematics here on Flexboard View, and we'll go through our list of power rails. So the first thing we want to look at is going to be our PPBUS G3 hot. So if we click here on our PDF version of the Flexboard view, we can see exactly where our PPBUS is. And the fuse I checked specifically was F7140. Let's just take a look at that underneath the camera. So with our multimeter in voltage mode, our battery unplugged, let's test and see what we are getting when we have the power supply hooked up. And on one side we're getting 0, and the other side we're getting 8.6. So our fuse is blown, and just to confirm our fuse is blown, we'll put our multimeter into continuity mode and just test both sides and see if we get a beep. Yeah, no beep, so this is completely blown. So let's see if there is a short to ground like we assumed on this side. There is. So we do have a short here on our PPBUS. We need to just find where the short is actually located. So let's think, what else can we look at this time? Let's go back to our schematic. Let's go ahead and pull the logic board out of this computer so we can just check to see if there's any corrosion, anything that'll give us a hint to where a short might be hiding on our PPBUS line. Alright, so we got our board out. I'm going to switch this over to our microscope camera. And now let's just look around for any visible signs of a short on our PPBUS, such as any blown any blown capacitors or any corrosion. Right, area around the LVDS looks okay. Our PB3V42 generator looks okay. Battery looks alright. All this around the CPU looks okay. Let's look at the underside. So far, I'm not seeing any signs of corrosion or heat damage. Our system management controller looks okay. So it does not look like there is any signs of rust or corrosion, so this one does not appear to be a liquid damage. Alright, so most importantly, let's make sure that our CPU V core and PPBUS aren't shorted together. Let's see, where's CPU V core on this one? It's going to be the capacitors next to the processor. We just need to find out exactly which one is. So CPU V core should be right over here. Okay, so right next to this giant coil, we're going to have a resistor. And let's just measure that to our fuse over here on this side of PPBUS and see if they are shorted together. And they're not. That beep was that there's very low resistance, very low impedance between CPU V core and the and ground itself. We were reading 13 ohms, and CPU V core is always going to be CPU V core is always going to be a low impedance. So the fact that we were getting about 13 instead of 0 shows us that CPU V core is not shorted to PPBUS. What that means is that we did not send the full power of PPBUS directly to the CPU, so this is not brain dead. So this is a good one. We just need to figure out what is shorted. There's no liquid damage. At this point, a please bro camera would be handy so we can inject voltage and see what heats up first. Instead, we're going to do this without a thermal imager and just inject a small amount of voltage through our PPBUS and feel around the board and see what gets hot. We are also going to use isopropyl alcohol and see what evaporates first. So we'll switch this over to our overhead cam. Let's put away our MagSafe 2 adapter for our power supply, and let's just get a standard banana clip. We're going to solder a wire directly onto the side of the fuse that is shorted. We're going to inject a very low voltage. We're not going to inject the full 8 volts. We're going to start off with 2 volts at half an amp and work our way up from there. Okay, so if we're going to solder a wire, let's make a wire. We got some extra wire here. That's good. The fuse is so large that we won't need our microscope. We can actually do this all by eye. And our flux is doing something a little funny right now. Just going to clean that off so we can get a nice even touch of flux right here on our fuse. The reason we're not replacing the fuse is because, or replacing the fuse yet, is because that's not where our issue's at. Our issue is we have a short somewhere on the right side of PPBUS, and it pulled enough power through the fuse that it actually blew it. If the short is still there, if we end up replacing the fuse now, we're just going to blow the fuse again. So we have to eliminate the underlying short before we can actually replace our fuse. So I just went ahead and tinned up that side of the connection of the fuse itself. And let's do our wire facing here without burning myself. Nice. That's a nice connection. So before I connect my leads, I'm going to go ahead and change my power supply so we don't inject 16.5 volts directly into our shorted PPBUS. So we're going to drop it down to about 1 volt, and let's do 500 milliamps or half an amp. So now that we have that set, you're going to put your black probe on ground, which is going to be any of these copper contacts, or you can even touch the USB ports. I like to connect our black right here to a screw standoff, or where a screw hole goes. And red on red. And let's turn on our power supply and see if it starts pulling what we're asking it. So at 500 milliamps, we're pulling 0.07. Let's increase the voltage up to 1.5 volts and see if it starts pulling. Alright, let's increase our amperage up just a little bit. So we're still staying, okay, we're increasing it now, so I've increased the amperage up from 500 to 800 milliamps, and we're drawing 0.14 volts. It's not going to be enough for us to feel any heat just yet. Increase the amperage just a little bit more. Let's go to 1 whole amp. Okay, so with 1 amp we're still pulling 0.15. Make sure we have a nice solid connection here. Okay, so we're pulling 0.16 volts at 1 amp. Nothing on this side of the board feels to be getting warm. So let's flip it over and see if our short might be on the other side. And what I'm doing is just feeling around the board for any sign of heat. And it all feels to be pretty room temperature. Nothing feels hotter than the other yet. So the term I used earlier was a please bro camera, and essentially what that is it's an infrared camera. It's also about $700, and what it does is it has a special feature to where it'll show what the temperature of the board is, and you can press a button and it will isolate the warmest part of the board. And that will give you an idea, if not the exact answer, of what is shorted. You can also cover your board in isopropyl alcohol, high grade like 90%, or I like to use 98, 99% isopropyl alcohol. And whatever evaporates first is the indicator of a short. And yeah, everything feels okay. I know one recommendation Jessa does for iPhones is put the logic board up to your face and feel whatever gets warm. And that works for iPhone logic boards. This is just a little bit larger. So we're drawing about 1 amp at 0.22 voltage. Increase the amperage just a little bit more. and we're drawing about 0.29 volts. So it's consuming not that much voltage, but really it's the amperage that's the most important. That's going to be generating heat. Whatever is shorted, it is very small. Like the component more than likely is going to be small. I'm going to increase the current just a little bit more. Let's flip it over one more time, see if maybe it's hiding on this side. And you can really hear the power supply holding back the current. We can't control current, but we can resist it. So the fan itself inside the power supply is just resisting the amperage that it's trying to consume. Okay, well, I'm going to let that warm up just a little bit. Let's go over to our board view and just get another idea of what is all connected to our PPBUS. So on this side, we have a couple of resistors, and I don't see anything immediately over here that is ground. Over here, don't really see anything. This side looks okay. On this side, I really don't see anything either, so we're probably going to have to look at our PPBUS high side, which is close to our 5 volt, 3 volt power regulator. So let's look at that underneath our PPBUS. We can see directly underneath, we got PPBUS S5 high side computing ints. And we got a lot more capacitors, which means a lot more area for ground. So let's feel around those caps. And immediately, I'm not feeling one cap that's hotter than the other. And usually these larger caps would pull a lot more power. So let's look over here. And feeling around. Feels okay. And these are all capacitors too. And the problem that we have here is we're injecting, or we're only getting about 0.14 volts. It's really not enough. It's really not enough for us to generate enough heat, but I don't want to inject too much amperage to increase the voltage, because we could have a short on a MOSFET that's right next to our 5 volt and 3.3 volt power regulators. And the whole point of a MOSFET is to jump power between like 12 volts back to 0 to average it out to a smaller number like 5 volts, 3 volts, 8 volts. And if we have a short there and we start injecting too much power, and something that requires low voltage, let's say 3.3 volts, We don't want to send any more than it can handle and end up killing it. We're here to fix boards, not damage them. Increase the current a little bit more. Alright, so we're not really making much progress over here. So before I cover this board in alcohol, let's take a look at our schematics to see what could lead us to our issues. So our short is at our PPBUS G3, and just to make sure, PPBUS S5 high side computing is going to be the same. So if we put our multimeter into continuity mode and we just measure, see, we have a full short right here. So our PPBUS S5 high side computing ints is directly related. Let's see if there's anything immediately else that could be shorted from this. Let's take a look. I'm pretty sure this is also going to be related. The difference is it's just other instead of ints, but this is all going to be our PPBUS as well. Yeah, and see that's shorted as well. All that is related with each other. That's what that beeping was. Let's take a look here. We'll just start off with PPBUS, and immediately looking at it, just right here, we see PPBUS does go to this guy, this MOSFET right here, that is ground, and also goes to our backlight as well, which just goes through a series of parts that go to ground, but that's getting off track. So I don't think that's where our issue is going to be. So immediately with PPBUS, we are looking at least one MOSFET here, but let's look what PPBUS is created by, or actually let's look where this fuse is and kind of go from there. So on fuse F7140, that creates PPBUS. And this side, line 2, is the part that is damaged. So PPBUS is going to be listed on these pages right here, 27, 41, 42, 49, 56, 62, 64. Let's just copy our PPBUS and go to those pages. Alright, so PPBUS and PPBUS S5 high side computing ints has this resistor that they share, but they also go here to U5450, which, let's see, this is almost looks like a current sensing resistor we got here, and we have our 3V 3SO that goes into U5400, which creates SMC high side computing ints. Just to rule out we don't have anything weird going on here, let's look at this resistor right here. Oh, that's hiding underneath stuff. That didn't help much more. Alright, but that's immediately right next to our system management controller. I had to take care of something real quick. So I was just thinking about it, and new camera system until we get the new recording system set up. So I'm thinking maybe the connection I just soldered on actually wasn't a good connection. Let me touch that up real fast so that we can see if that is going to give us any better results. Let's take a look at that underneath our microscope. That's better. And I'll just unplug our ground and make sure we don't inject too much current. Let's see if that fixed our issue. Okay, so immediately plugging in, we're still getting about the same, the 0.14 volts. I'll increase the current just a little bit, and the current actually just stopped because we dropped this too low. Bring this back up to about 2.5. So we're drawing about 30 volts. We're just feeling around again. Still not really feeling anything here. So what we'll do now then is we'll just put some isopropyl alcohol on our board and see what evaporates first. Nothing over there. See, I'm worried that we're just not getting enough consumption, because even if we look at where we soldered our wire onto our connection, it's not melting, but then again, or evaporating, but then again, where our short is will be where it evaporates, because that's where ground is. Now let's check all of these capacitors. Check that guy again. Yeah, it just didn't have enough isopropyl alcohol in it, but I thought that was a clue, so that wasn't it. Let's keep moving along. Nothing looks like it's necessarily sizzling over here. Stay away from that area. Let's look at... Oh! I found it! Alright, we can turn this off. So this one was a little tricky to find, but after taking a better look at it, if we look at this capacitor, we can see the one that's cracked in half. Guarantee that is our issue. And we did look earlier on our schematics, and we did see that that is going to be part of our PPBUS high side computing ints. So let's go ahead and repeal and replace this guy. First, we'll just remove it and see if that resolves our issue. Let's flip this over to our microscope camera. And for this guy, we get to use our tweezers, our micro tweezers. So we'll need to plug them in. So we'll apply some flux, and some tricks we can do to make this capacitor come off easier is we'll take some flux and go ahead and apply it onto one side of our capacitor. Let's see if I can get down in there with the other, with the micro tweezers. They're in there, so let's touch this guy up. This guy is right there. And then the last thing we can do to try to make this come up easier too, is you can take some low heat. You can take some low heat from your rework station if you got one. And we're going to go ahead around the capacitor, and what this is doing is heating up the ambient temperature around the cap, such as the ground, and make this guy come off easier. And we have the rework station on a very low setting. So this one's set to about 200 degrees Celsius. So it's not going to cause any damage or heat up anything else around it. Just enough to warm up the ambient temperature. Alright, we're starting to get some play. And our ground is up here on the top part. There we are. Set that guy to the side. Ooh, that one stinks. Oh, that one is awful. Oh, God. Oh, yeah. I think that was it. Oh. I'm going to have to continue this with a mask on. Oh, don't want to get sick from that. Alright, let's see how well we can do this through the mask. Sorry, this is awful. This one is really, really bad. In fact, I guarantee that's just a tantalum capacitor, which is probably why this one smells so bad. Let's see, what is this guy? So that was you. Now let's look you up on the schematic. Yep, that is a polymer tantalum capacitor. Those things are awful. They're not good at all for your health, too. Ugh. Okay. Let's switch back to overhead cam. Let's see, before we replace that with a new one, and it's hard to see anything with this mask on. I can't put my face all the way up. Let's see if that has resolved our short. It has. No more short on PPBUS. So this tantalum capacitor here is the ultimate issue. That's why this wasn't working. Let's replace this, and then we are going to replace our fuse. The what was it? The F7140, I believe is what it was. Yes, that's exactly what it was. So let's get a donor board here. Man, that was awful. Oh, I think I got donor boards actually down here. Yeah, we have some right here. Let's test and see if this one, if its fuse on PPBUS is still good. It is, so we'll be able to take that. Let's make sure that PPBUS isn't shorted on this one either. This one's fine, so we'll use this one as our donor board. So let's switch over. Set our main board to the side. We'll get our donor board in view. So we're going to take this guy the exact same way we just took ours. All of our stuff is in the way. There we are. Get that back. Load that guy up with some good flux. I'm going to increase the temperature on my quick from 200 to make this one fairly faster. We'll do it 275. So that's on, and just like before, we'll take our micro tweezers and we'll touch the capacitor. We'll also put some solder onto the positive and negative side, and this just allows the solder that is currently on there to melt a little bit faster. Now we'll use our rework station. Go around in a circle, and this guy should come off easier than the last one did. Alright, so there's that one. We'll set you to the side. While we're at it, let's go ahead and grab... Ooh, this one stinks too. Nowhere's as bad as the other one did. Alright, while we're at it, let's go ahead and grab... you know what? This donor board still has a Wi-Fi card on it. Let's remove that first. This may or may not be a good airport card. No sense in wasting it. And since the fuse does not have ground, this one will come off a lot easier. turn this in an angle to where I can grab. Where'd you run off to? Right here. And just like before, I'll touch it up just a little bit. If we want to be a little fancy, we'll get our air station to heat up both sides of the fuse. And just like our capacitor that we're going to use, we'll set that to the side. So, donor board, you've served us well. We'll put you aside. Patient board. Let's fix you up. When it comes to replacing a capacitor, especially a tantalum capacitor, you want to keep the orientation correct. So you want to make sure that the line is facing your positive line, or it's actually just on the line itself. So our PPBUS, and the other side is going to be our ground. And my tube here of flux has been doing something strange to where it just constantly leaks. I've just used my tweezers to scrape some off so we don't waste any good old flux. Now this isn't going to go on perfect just yet, not until it heats up a little bit more. And just like before, we'll use a little bit of heat. This is mostly to heat up the ground side of the capacitor. It goes on better. So that side just heated up while I still have some control. Let's push this down. That one's done. We're going to clean all this up in our ultrasonic cleaner. It'll look a lot nicer afterwards. Let's move over to our fuse that's blown. We no longer need our jumper wire, but we do need to keep our airport card. This one should still be fine. We'll test all that out after we actually boot this computer up. And we still have some leftover alcohol. That's all that this stuff is. In fact, actually, if we take our quick station, we'll see the stuff just evaporates instantly. That's because this is the high percentage, the 99%. So there's very, very low water content in here. Not enough for it to actually damage anything. Just like before, we'll put some flux. Again, the whole reason why we're having to replace this guy is because we had an underlying short, which turned out to be a polymer capacitor, polytantalum capacitor, right next to, or that was on the PPBUS high side computing ints line. And since it blew, this fuse here popped too for PPBUS. It should have saved the rest of the computer from getting any further damage. And now that we've resolved the short, we got to replace the blown fuse. Replacing the fuse alone would have not fixed the issue. It's very rare for fuses to just blow without any other issue. There's got to be some sort of surge or a short that consumes more power than the line is regulated or the fuse is regulated, so it pops. So, there's our old one. Let's apply some new flux. And once again, it doesn't look pretty just because we're dealing with a lot of solder. Once we put in the ultrasonic cleaner, this one's going to look as if it was never liquid damage. I'm sorry, let me take that back. I'm so used to working on liquid damage devices. This one was never liquid damage, but once we put in the ultrasonic cleaner, it'll be difficult to tell that we ever worked on it. Force of habit. Most of these computers that come in here are liquid damaged. This was one of the rare cases where the board had just failed on its own. Alright, that looks good. Let's switch over to our overhead camera. Okay, it smells a lot better now. Let me take off this mask. Much better. Let's see if this one will turn on without having the power supply. The battery might have just enough to actually turn on. And it doesn't look like it. Yeah. So we'll need to hook, oh! Forgot, after a battery being unplugged, it needs to, oh, we'll cover that. So after being unplugged, the battery itself does have to after the battery is unplugged, the computer itself does have to power cycle at least 3 times before it boots up all the way, and it's very possible the battery didn't have enough charge just now. Let's grab our MagSafe 2 adapter. And before we plug it in, we'll have to change the voltage and the amperage on our power supply. Since the MacBook Air will use 16.5 volts. How you can figure that information out is just look on the back of a MagSafe 2, 45 watt or 60 watt, and it will tell you 16.5 volts at 4 amps. So we got that plugged in. Let's see if we get fan spin. We do. We got a fan spin. Let's see if it power cycles on us or if it boots up all the way. Sounds like it's going to boot up all the way. I'm just going to cover the name so you guys don't see this customer. But it is successfully booted up, so that is a successful logic board repair here. So just to reiterate, everything that happened on this one is we had a blown fuse on our PPBUS. Specifically, it was the PPBUS fuse, the F7140, and instead of replacing the fuse, we went and we looked further onto the other side that was blown, which was the PPBUS high side computing INTs side, to find our short. It was a very difficult short to find just because we weren't drawing enough voltage to generate enough heat for us to just touch around on the board. Even with my hand touching directly on those capacitors, I personally didn't feel anything. So we tried the alcohol method, which is a fairly inexpensive method of locating where a short is, because a short does generate heat, and in turn the isopropyl alcohol will evaporate wherever the short's at. We got very lucky in this sense. Well, I shouldn't say lucky. After further examination underneath the microscope, we were able to see that the capacitor itself, right next to the processor, which is still our PPBUS high side computing INTs, that it was just clearly cracked in half. That's enough of an indicator to tell that it needs to be replaced. Once we removed that specific capacitor, it then resolved our issue. And just to show you that on our schematics here, if we pull it up, so this is connected to our PPBUS high side, S5 high side computing INTs. It is a capacitor. The other side is ground. It's C7377. And let's take a look on that on our schematic, which is right here. And this is responsible. It's smoothing capacitors. And what is it actually smoothing? It is a smoothing capacitor for our PPBUS high side computing INTs that goes into, if we zoom out a little bit, these are going to be our CPU power regulators. We got our phase 1, phase 2. So this is actually what, in the end right here, this is what creates our CPU power. So it was a good thing that our fuse blew when it did, our fuse over here, because if it didn't, then this would have been drawing so much power over here on C7377 that it actually could have brought the full power from PPBUS, the 8 volts, directly through. Well, thankfully there's a lot of smoothing capacitors to prevent this, but it could have made its way to our PPVCC SO CPU, which, as you can see here, is a 1.85 volt maximum line. So 8.6 volts going directly into 1.8, that would have killed our processor. So the fuse did its job. So now we got a working MacBook Air. I'm going to do a quality control test, and then we're going to put it in our ultrasonic cleaner and call the customer, give them the good news. But I hope that this was a good learning experience on how to troubleshoot where a short is, especially on a main power line such as PPBUS, using just some pretty rudimentary methods with isopropyl alcohol. We didn't use any freeze spray. That would have been way too much, and we didn't inject too much voltage because we were afraid we would have potentially killed this. That's it for now. If you enjoyed these videos, please let me know in the comments below. I'm trying to get them more regularly created, and I'm trying to build a new computer, being that Windows 7 is going to be discontinued, I believe the 14th of this month. So we got to make moves on what we're doing. That being said, thank you so much. We'll see you in the next one. Bye.